Okay, so we start go back to building maintenance management, the last slide that we looked into, or last to last slide that we looked into. So, I was telling you about the role of maintenance management in overall building process. So, basically as construction starts with owner and user, building construction starts with owner and user, right, initiating it, and then gives a brief, that is requirement, etc., followed by design, and obviously the constraints will be financial and other constraints. So, optimal spatial as well as physical environment, taking everything into account, both structural design is also a part of it. The design is done, and then design, realization of the design is construction, but at this stage itself, in the beginning itself, for what purpose? The function of the building is decided and its level is decided, right. For example, the hotels can be of different kind, hospitals can be of different levels. So, what type of maintenance requirement, that right in the objective, its objective is already decided by the owners or user, and then once the design is over, the construction is a realization, and in between comes the cost, quality control, etc. And there itself, during the design stage itself, you fix up the maintenance manual, what should be done, because the design decisions are related to, or maintenance is related to design decisions. Then followed by this is construction, which after the construction as built situation, also you are given guarantees and warranties and all that. Then here, once the objective is known, the guarantees, warranties are known, maintenance manual is available to me. Every 5 yearly, I survey the physical condition, maybe every yearly I do some inspection, and then financial situation, I see whether I can maintain this building or not. If I can't maintain this building, then obviously I go for demolition, end of physical life, functional life, or something, as we said, or else I continue the maintenance, as it is supposed to be, facility as needed, right, according to the currently acceptable standard, and my information flow also takes place, feedbacks are always given, etc., etc. So, this is what is the role of maintenance in overall maintenance management. Then I was looking at what generates maintenance. I think that is what we are looking at. We said the agencies are, one is the climatic condition, and they have their major effect on external factors. For example, rain, wind, etc., etc., particularly wind driven rain, and they would result in deterioration of certain element or affect many things. For example, in moist environments, even any steel or metal will start corroding and so on. So, therefore, environment has got an effect. Also users activity, like I mentioned in the last class, that users activity includes, say for example, users activity for, I was giving an example of an industrial situation where there will be a lot of abrasion in the floor, because some heavy machineries might be moving, some cranes might be moving, similar things, and that will result in deterioration of the floor, and therefore, you have to do it maintenance periodically. Also sometimes because of simply change of standard. Change of standard means currently acceptable finishes. This is most realized in the finishes. Of course, some cases the other situations also standard changes. Like I said, the risk perception related to earthquake, which has changed. So, such would mean that you retrofit it to the current requirement, or energy perception has changed, you need better energy efficiency. In that case, you might retrofit it to currently acceptable energy code, all right. So, and this might change with time to time, technology would change. Some cases technology will change. For example, lamp technologies have changed significantly over last 10-15 years. So, where you used to have maybe incandescent lamp or fluorescent lamps, now you have got CFL and then LEDs. So, there is a change, and therefore, they are the system might be technologically better, maybe new. Earlier we did not have network requirement, the new services would come, depending upon requirement of network, Wi-Fi facilities and so on. So, all these are also generates a kind of maintenance, not necessarily it does not, I mean, if the current situation has not worsened, but there is a change of taste or change of requirement. So, therefore, there is this change in standard also generates building maintenance. So, you would see that generally users requirement will tend to increase, users requirement will tend to increase. So, if I see building as a whole, a single building as a whole, for it is not single for a given item, it may not be for a given item, in general is being talked about, standard or such requirements go on increasing, and anywhere the deterioration that occurs, this goes on bringing the current state, if I may say current standard, current state, it will deterioration cause it to go down. So, this is maintenance, this might be some sort of improvement, right, but basically that goes down, that goes up, and original condition is somewhere here. So, in building maintenance scenario, unlike let us say mechanical system, automobile generally changes in the system unless you are retrofitting into let us say petrol engine to a CNG engine or something, or diesel to a CNG engine. Usually most of the time it is not the case, you just replace the same part by the same part, and if you do not get, if it is obsolete, then it is obsolete, the the automobile itself might become obsolete. Similar situation with many of the even other consumers items, right. So, obsolescence is there, the obsolescence is there. So, they would say that the manufacturer has stopped producing that product, like Maruti 800. Now, supposing you have to have Maruti 800 as some parts is bad and you want to change it, in that case you may not get it from the original manufacturer, they might stop it after once they have stopped the production of the car, they might have stopped production of the spare parts as well. So, there this situation do not arise, but here what happens is in buildings, building is very much there, obsolescence is there, but relatively less, but more importantly what will happen is there is a change in taste and standard or even requirement. So, frame, skeleton, structure, building, its function might not be changing, but you might change simply the other finishing items or similar sort of thing, there could be changes. So, both improvement continuously goes on here, improvement continuously goes on here, and that is why there is an increase, and then you have to bring it back, some of those items which have deteriorated you have to always bring it back to its original standard. So, this would require maintenance, there is some always improvement part in maintenance. So, when you do maintenance planning, one has to look into both, at least some sort of one should have some sort of idea that this is likely to you have to budgeting and all, you have to keep that in mind. So, general consideration one can have. So, what you see the cost wise, maintenance cost grows with time in this manner, right, and if you do not take care of the deterioration, value loss will happen in this manner. If you take care of the value loss do not start all the time from the right in the beginning. Some cases value loss you start realizing later on. For example, deterioration in some cases may not take place instantaneously, it might take some years, it is fine, then it surfaces. Actual deterioration might be taking, the value loss might show up later on, all right. So, so value loss in some cases, there is for example, some internal deterioration is occurring, it may not surface immediately, it might take somewhat longer time. So, this some cases this will be the model, some other cases this will be the model. So, both can happen, value loss can show up later on. So, that is what it is. Now, how much these agencies or they would affect your maintenance program, that depend upon extent to which actually this maintenance generators effect depends upon obviously severity of the climate, and depends upon severity of the climate and how much you have actually foreseen it. So, and if you have foreseen it, then the design and the sustainability of the material will be specified. In the design itself you can do in such a manner that it can take care of some of it. The maintenance requirement will be less. For example, use say pipes, GI pipes. Now, GI pipes, they have their life, or let us say I give another example, electrical wiring. Now, you might decide to use aluminum wiring, or you might decide to use copper wiring. The life of copper wiring possibly will be more, 25 to 30 years, whereas aluminum wiring you might have to replace after 15 years. So, if you have envisaged the scenario, seen the scenario, foreseen the scenario, and how much you have designed for. So, the extent of damages that you would see would be depending upon the design, right, in the design stage itself what you have foreseen. Then obviously, the workmanship, standard of workmanship is important. Standard of workmanship is important. If the workmanship has been good, if they have constructed it well, you may not have much problem of maintenance. I just give you an example. Normally, you will see that it's quite often what happens is if you have let us say this is your section of a flooring, and you have a trap here, gully trap, right, flooring of a bathroom, shower room, So, you have a gully trap here in one of the corners, somewhere in the elevation is like this, should have a good slope. But quite often, if it has not been done properly, you might see that the trap is here. I mean, in plan, if it looks like this, something like this, here is a trap, plan, let us say, and you will find that quite often what they do is they put in a kind of for jointing purpose, they put in some sort of a cement mortar joining, and if it is not done, leveling properly done, actually there will be, or the slope is not proper, you will find water accumulation in all over the place, water accumulation all over the place, right, for a longer period of time. When it should have drained off straight away, you will find that it takes long, or sometimes it simply holds, or some other very peculiar sort of construction details problem comes. So, if the water is sorry, excuse me, if the water is stagnant here, standing there for a long time, it would have a tendency to cause seepages in the long run. The flooring that would be exposed to water for a longer period of time, absorption, capillary absorption, etc., etc. So, this is one situation, but supposing the slopes were proper, this is also proper, that it just simply drains off instantaneously as that it should be, then so the workmanship plays a big role, therefore, construction workmanship. Another example, what sometime you might find, cases of I mean this you find normally in buildings this happens, buildings where the construction, some of these are relatively manual work, skillful work actually, this, and if it is not done skillfully, then there is a problem. Another example I will give you, you might have seen balconies, you might have seen balconies, and then you have a railing there, right, you have a railing there, of course standing railing should be there, standing railing should be there. This is a balcony floor, right, this is a balcony floor. So, railing there, etc., railing standing there. Now, you normally should have a what is called a spout hole here, so that any water, rainwater coming, and this should be mildly sloping, and rainwater should drain out. Now, supposing the spout hole pipe that is fit in is 1 inch above the bottom level, then after the rain you will have always stagnant water up to that 1 inch. Actually, it should be exactly matching with the flushing with the floor and draining. So, such details which quite often are overlooked. There may be also a situation, you have a sunshade Now, in a sunshade you might have a drip course, you are supposed to have a small drip course here, and if it is missed, the water would always be. So, these are detailing construction qualities. So, water will have a tendency to flow inside, but if there is a drip course, then this would have come down straight away, it would have come down. So, these are some of those workmanship issues which would lead to actually extent to which you will require maintenance, extent to which you will require, right. So, standard of workmanship and standard of design as well. So, design, like I gave you an example of, by choice I have taken copper, instead of copper I will be using aluminum, or similar sort of thing. Many places by choice you do, and that is what it is. So, this is what actually the extent to which I need maintenance will depend upon that, and therefore, actually I can do planning right in the beginning as much as possible. Okay. To do that, what we do is we classify materials or systems into different classes. So, at least first thing what we can do is we can classify them into simple 5-6 types of elements, right, 5-6 types of elements. So, first one, now typically the standard will have a tendency to go up, right, and some items will be related to standard changes, not everything will be related to standard changes, right. So, this one actually gives you the bottommost line. To start with, I have started with started here, essentially the standard in the beginning is here, standard in the beginning is, somewhere I put in here, standard in the beginning, acceptable standard somewhere in the beginning is something like this. Now, standard overall will go on something like this, it will go on improving some cases, not all elements, some elements there is a chance of standard going up, some elements that so therefore, one can think in terms of a boundary, that this is my level and this is my lower level, this is my upper level, this is my lower level, and actually things might be vary between the two, though that standard changes occur actually, standard changes occur, but this is the minimum acceptable level. Notional, these are notional. For each type of element, quantification will be different, units in which you express will be also different. Some other items could be there which do not change with time. For example, foundations, there is no question of changing, and its standard is also unlikely to change. Structural system, they are unlikely to change. There is of course structural deterioration you do see, foundations also might have a problem if the design has not been proper. For example, if the soil characteristics has not been estimated properly, foundation design has not been proper, the consolidation aspect of the soil, long term soil consolidation, that has not been looked into properly, you might find there is tilting or something of the building as a whole. So, these are not really, there is serious, not really maintenance problem, and you do not expect them to happen. You expect that design should be adequate, right, design should be adequate. So, normally we assume that structural system and foundation system, they do not really show up much of a problem, and I can leave the standard as themselves. Having said so, I would like to qualify some cases. In the beginning, if I am planning, I may think that nothing will happen, but still over the time you might find somewhere that this is occurring, right, this is occurring. So, you take care of that in kind of a what you call contingency budget, if that is there, but to plan with, I do not think foundation will have a problem. So, foundation and structural system, frame, etc., should not require maintenance, right. Steel structure would need, because I may have to do painting, structural steel member, if they are not encased, but usually in building they are encased from fire point of view. Okay. Now, certain items should be there which shows a kind of deterioration like this, which shows a kind of deterioration like this, shows a kind of deterioration like this, and the moment it reaches a normally acceptable standard, you repair it, bring it to its original state. So, we talked of certain items where standard change will be there, possibly I can think in terms of a range in which they will operate. Some items, item number 3, no changes at all, foundation and structures. Third, I am saying another kind of one which will show there is a slow deterioration process. The moment it reaches some level, I repair it and bring it back to its original state. Then again it will deteriorate, and this kind of cycles of repair I would need. So, we have now classified at least 3 to 4 types of item, 3 types of items. Structural frame, etc., do not need anything, they are not supposed to in the planning stage itself. Then there are certain items where deterioration would occur, for example, external finishes. Depending upon the environment where you are, you need external painting to be redone after a certain period of time. If it is painting or even exposed concrete structure, you may have to do washing to remove the algae and such things. So, deteriorates over a period of time slowly. Then you bring it back to its original state. And if there is a standard issue there also, but it is normally that standard issue should not be there. Okay. There are certain items which fail suddenly. For example, water supply line, it fails suddenly, complete failure. So, it goes right up to the bottom, and you have to restore it back to its original state as quickly as possible, right. So, with time, this is a life cycle, life of building. So, erection to the demolition time. We have classified, we see that we can classify the item into 3-4 classes so far. One is where standard changes would be there. So, there is a band in which they can operate. The second one which would do not need any kind of changes. The third variety where slow deterioration takes place, I bring it back to its original state, and the fourth variety sudden changes. A fifth variety is so slow deterioration that what I do is I keep it at higher level right in the beginning. So, slowly it will deteriorate and reach to a level after the end of the life to an minimum acceptable state. Since the buildings, as I said, were very complicated and they have large number of items of varieties of trades involved. You will have civil, mechanical, in mechanical plumbing services, electrical, and today possibly even computers, IT involvement, telecom and IT involvement would be there. So, so many trades are there all together, right, and therefore, varieties of items, it is better to classify them, all will not show similar kind of maintenance requirement. All right. So, to take care of this, we define, we actually just to take care of this, what we do and why we are doing this. First of all, we would like to, if I classify all the items in different classes, right, then I can each item, type of item wise, I can see their maintenance need or periodicity of their maintenance. Periodicity of their maintenance, right, periodicity of their maintenance, which we will look into. So, periodicity of their maintenance, while something will require, like I was given wiring, rewiring to be done, that would be 25 years or something of that kind if it is copper wiring, because we know that it would give up after a certain period of time. What will actually happen is there will be too many possibly emergency calls because of short circuiting or something like that, loose, I mean the wires should have given up or whatever it is, insulation would give up. So, possibly it may not be worthwhile to continue with the wiring beyond 25 years or something like that. So, I know this item, this is one kind of item, while external painting is another kind of item, where standard or internal painting particularly, where standard might play a role. So, structural items, there is a third variety of items, plumbing services, water pipelines, etc., pipelines, water pipelines or wastewater or drainage system, they are another variety. So, large number of them I can actually classify them into several classes, and when I am able to do that, periodicity of their maintenance requirement I can find out. While if it is plumbing services, I do know that in possibly depending upon the situation, cast iron pipes, if they are there, the main pipeline coming to the building, let us say, as we discussed earlier, maybe it will last for 30-35 years because of the rusting scenario or internal deposition if you are using groundwater. Groundwater sometimes, if it is not decanted properly, if the suspended matters are not really separated out properly, it might cause deposition onto the pipeline themselves. This is what the case in IIT actually they had. So, they started replacing after 30-40 years or so. So, but in between you may have to do sudden repair. Therefore, such items you cannot plan it. Sudden repairs cannot be planned. Where you know the pattern of deterioration, where you know there is a slow pattern of you can actually plan. Right in the construction phase, you can plan that okay, every 5 yearly I will have to do this maintenance, and you can budget for it, and the budget or planning, as we said, maintenance manual you can generate. So, you can generate this, right. So, that is what it is, but to do that what I got to do. So, scheduled maintenance relates to this as much as I should be planning. I will talk about this later on. Now, in order to do that I need to quantify everything, right. How do I say, on what basis do I say that I got to change the external painting or external facade look of the facade after every 5 years or after 10 years or something like that. So, I must have a way to quantify this. The quantification may be in different ways, not necessarily. I might say there could be several. Some cases it would be possible to express it in physical terms, measurable physical terms, right. External painting of course is not really necessarily look may not be measurable materials term, but some other items I can simply measure. Supposing some losses of dimensions are there, some places I can measurable items could be there. Some places I will be able to measure, for example, the reflectance of the surfaces. This has got a relevance in lighting, both artificial as well as daylighting, because light from even the lamps, they will be reflected from the walls and reach to the room. So, general level of lighting in the room, reflection has got a role. So, if it is of course, it is functional building like classroom or similar sort of situation. If it is a living room, it is the decoration part of it. One might like to interior decorator might decorate the way they like. That is a different one. That is not the but where is functional requirement of the lighting is there. You might like to know the reflectances should not go below 0.7 or 0.8 or whatever it is. There we term something called maintenance factor. We take a maintenance factor, right. So, one can measure this in fact. Measure how? Use a lux meter. A lux meter measures light. So, lux meter you first face it towards it. If you face it towards it, it will show how much light is keep the lux meter on top of the surface. So, whatever light is coming in reverse its direction at significant distance, sufficient distance, one can do that experiment and find out how much is reflected back. The ratio of the later to the former will give you the reflectance of the surfaces, right. It will give you the reflectance of the surfaces. So, this is measurable item. So, you say the reflectance goes below 0.7, I got to do the internal painting, or even below 7 you might see 0.75 or something, because you will be planning. So, there are quantifiable item in functional aspects also. Several things you can actually quantify. So, some cases is measurable, standard can be measured. So, so also over a long life of building, users will tend to come and as we said already, standards etc. So, some certain elements maintain a constant condition, that we have already said, over the life of the building, while other subject, this I have discussed already, subject to unpredictable failure. Also over a long life of building, users will tend to come and demand higher standard, therefore, repairs and revisions invariably go some content of improvement, which I have shown you and I have just mentioned. So, standard may be expressed in following ways, physical terms, that is what I say.